Hi guys, welcome to MLOPS Explained video. In this video, I explained about MLOPS, its architecture, and the components of MLOPS. In the end of this video, I also explained about the project and also shared some resources to learn about data science, machine learning, and MLOPS. So let's just start the video. There are some problems always which we face when we build a machine learning project. We have to run each step again and again to run our model. So what if there is a way to automate this? So the way to automate it is MLOPS. MLOPS is a collection of procedures that attempts to install and maintain machine learning models in production in a reliable and effective manner. It is a combination of machine learning with DevOps continuous deployment methodology. MLOps is used by data scientists, DevOps, machine learning developers to move algorithms to production systems when they are ready to use. MLOps aims to boost automation and raise the caliber of production models while concentrating on business and regulatory needs. MLOps solutions provide the constant monitoring and management of model usage, consumption, output to guarantee the model accuracy, performance, and other output results that are acceptable. There is one more point called model governance. Model governance is a reliable models that are essential for applications in the actual world. So this is the small architecture of end-to-end machine learning project that shows the role of each person in a team. This whole process is automated using MLOps. In production, ML models and data can become so large that it can take days to retrain and deploy a model. So with the help of MLOps, we can easily deploy and retrain a model in various ways. So our next question is why MLOps is important. This is a data science project lifecycle that shows how a data science project is built in real life. It is difficult and complex to implement machine learning models in real life. Data ingestion, data augmentation, modeling, training, optimization, model experiments, and result explanations make up a typical machine learning project lifecycle, in which AI/ML engineers spend more time on data preparation, data cleaning, feature engineering kind of things. Another IT team managing the training and deployment of models. No model governance is there, no monitoring is there. We need to continuously monitor and enhance the models in production. No data versioning, no scalability, and more time consuming unproductive work is there to know about the dependencies. So all this kind of thing is there in a typical machine learning project. But you can offer better quality ML models and speed up model deployment with MLOps. Data preparations and feature engineering steps are automated. Better check for model degradations, drift, and change. Performance degradation, drifts, and data change over time because of external factors like customer behavioral pattern change on buying and doing some work. Model governance and data versioning along with model registry is also present in MLOps. Scalable automatic CI/CD pipelines, model deployment, and monitoring is also there. Continuous integrations, continuous delivery, and continuous deployment may all be managed, controlled, and watched. In other words, you automate every step of the process from development to deployment, and you continuously track logs, matrices, and performances using MLOps. Now, let us talk about the components of MLOps, combining those to make our end-to-end MLOps project. In machine learning projects, the MLOps range can be narrow and broad as project requires. While MLOps implementation in some projects may be limited to the model deployment process only. In others, it may be necessary to include everything from the data pipeline to model production. Most businesses use MLOps in the following areas. The first is exploratory data analysis. By doing so, we can get complete exploration about the data, about its insights, patterns, and features, all the things like that. And the next step is data preparation and feature engineering. We prepare data for our machine learning model. And the next step is model training and tuning. And next is model review and governance. And next is model inference and serving. And next is model monitoring for data degradations and drifts kind of thing. And the next is automated model retraining. So these are the steps we use to build a complete MLOps project. And these are the components that are really required in any MLOps project. Okay, So let's just take a look at complete MLOps project architecture that shows how a full project looks like. So here in step 1, we get the data. We get the data from various kind of resources. Resources can be databases, data warehouses, or cloud sources, any kind of a resource that has the data that comes to our project. We get the data from that. After getting the data, we need to perform some operations on the data. We need to load the data into our system first, and after loading the data, we get to perform some more operations like data cleaning as well. The data cleaning will clean the null values, junk values, or problems like variance is there, outlier is there, or problems like multicollinearity is there, the noise is there in the data. So all these things you can clean by using the data cleaning process in the data science lifecycle. So after the data cleaning part, now we have to do the feature engineering or data manipulation part is there. So in feature engineering, we get to know about the most valuable or most important features of our machine learning model that add more value to our machine learning model accuracy. So selecting a good machine learning model is also a very crucial part of every machine learning project. So after selecting a good machine learning model, we split our data into test, train, and validation sets. And after splitting the data, we fit the train data into our machine learning model, and then we train our machine learning model. After that training is done, now we have to evaluate our model on the validation and testing data sets as well. And after validation, we know that our machine learning model is working good and it has all the parts that we need. So now we can easily push our machine learning model into the repository as well. That is called code repository, or we can say GitHub, Bitbucket, or GitLabs as well. So after we put our code into the code repository, then there is a point called CI/CD pipelines. CI/CD pipelines provide you the workflows to automate the steps of machine learning project from data preparation to the model training part as well. And it also provides you the things to store the important features into the feature store, or your parameters into the feature store as well, so that in the future, if we retrain our model on the new data, then those features or those parameters can be extracted from there. CI/CD pipelines basically use the GitHub actions. GitHub actions work on the basis of trigger and events. When we push the code to our GitHub repository, it automatically starts the build process. The build process has all the steps of the model, that is from the data preparation to the model training as well. It has all the scripts added into the workflow. It runs those scripts one by one so that no part should miss. And those kind of GitHub actions can help you to automate your whole project. The CI/CD pipelines also have a feature in the workflows to fetch data from the cloud, as well as retrain our model on the new data. And it can also refresh the web apps that we hosted on the clouds or free hosting websites as well by retraining the models in their backends as well. We can also build a Docker image of our models that can deploy that image into the production and store those images into the repository as well, so that if in future there is any kind of issue with the production as well, and we want to go back into the our previous image version as well, so by using this we can already go backtracking, and we can easily go into the previous version of our code or data as well. So after doing all this, we have to monitor our model as well. So for the monitoring purpose, there is a application that is called MLflow. By using MLflow, we can monitor our machine learning models for various kind of things. Like we can check it for degradations, drift is there, and it can also provide us various kind of matrices is there. From that we can check that how our model is performing in the production as well. And we can also check for various kind of conditions or parameters as well. So MLflow is kind of a complete pack that can provide us all the things to check in our model, all the things to monitor in our model, and also it can provide us a very optimized way to manage our machine learning models in the production. So this is all the architecture, all the steps that we can do in MLflow, a complete end-to-end project. So guys, here is the new example of MLOps on AWS cloud, in which we explain that how we can implement MLOps on AWS cloud. So the first question that comes in our mind is what is AWS MLOps? So AWS MLOps is the process of managing and integrating machine learning pipelines on AWS machine learning services. It helps to bring data science to the fingertips on customers. So we can see that there are also like MLOps workflows are there that we can use to build a complete end-to-end machine learning project with MLOps implementation as well. And there are some kind of engineering that we have to do on AWS, like data loading, data extraction, and data transformation kind of things as well. Or we can use the AWS services like S3 buckets, Lambda instances, along with their database services like that as well. And along with that, we can see that the AWS MLOps architecture is also the same that I already explained in my last slide as well. It has also the same experimentations, kind of repositories there, feature store is there, their triggers is there. So like the architecture is always same for any kind of MLOps project, but there can be like a few features that we add according to the need of the project. And then we can see the orchestration pull based training architecture that use the Apache Airflow to schedule the task for continuous development and continuous deployment as well. And we can see there is a message based training architecture is also there that use the Apache Kafka and message queues to send the message to deploy and serve the models as well. And then we can see there is a step-by-step guide to build and end-to-end machine learning model using AWS SageMaker. AWS SageMaker is the machine learning services provided by the AWS. In this, you can create like whole end-to-end project on AWS, and then you can check for its accuracies, their evaluation matrices as well on AWS as well. Like you can see here, it is a confusion matrix, then precision recall curve is there, and then ROC curve is also there. So you can also like implement the best practices on AWS cloud, that you can always get the label data. If it is a not label data, then it can also create a problem as well. You can split your data into three sets, like the training, testing, and validation sets are also there. And like these are the like best practices that you can use to build a great machine learning model as well. So guys, I think that's all from my side, and I hope you guys like clear the concept of MLOps. And if you guys have any kind of questions, you can pin down in the comments as well. And thank you. Thanks so much.